So let's consider this question 5b. This is another piecewise function which consists of 3 subfunctions, and we need to get the limit to evaluate the limit of f(x) when x approaches to -1. Again, the -1, you can see that a -1 is the boundary value over here. Alright, for the -1 positive, meaning that a value greater than -1, it takes this function linear. Okay, from the when s takes the -1 negative, meaning that a value which is less than -1, the function will be the quadratic. So to get this function, to evaluate this limit, we need to find the right hand limit and also the left hand limit. Then only we can make conclusion. Okay, so get your right hand limit. So right hand limit, when you want to put the f(x) inside, you need to consider -1 positive is fall on which interval. Okay, which interval you have. So -1 positive, you can take a value which is greater than -1. All right. For example, is negative 0.999. So negative 0.999 will be somewhere over here. Okay, a value which is greater than -1. So with the function of f(x) we'll take is the 2x squared plus 9/4 x minus 1/4. And for this right hand limit, we can just use the substitution method to evaluate this right hand limit. We just put in the -1 here inside the x. 9/4 multiplied by -1 minus 1/4 and calculate. For the right hand limit, we have a -1/2. Let's look at the left hand limit. Left hand limit, okay, if we want to put the f(x) here, alright, the function, we need to consider the -1 negative. You can take a value -1 negative, which you take a value which is less than -1, a value a little bit less than -1. So the value which is less than -1 is fall in this interval. So this interval is defined, this function is defined for this interval. So I'm going to replace this f(x) by the linear function. That is my 3/4 x plus 1/4. And again, I'm using this substitution method to evaluate this left hand limit. Substitute -1 in here in function. You get a negative 3/4 plus 1/4. Then finally, you get a negative 1/2. Alright, so since you have a left hand limit and a right hand limit having the equal answer, we can make our conclusion. This is our reason. Since the limit of x approaches to -1 positive of f(x) is equals to the limit when x approaches to the -1 from the left, and both of them equals to -1/2. Alright, since these two limits are the same, alright, equal, we can say that the limit for the two-sided limit, which is the limit when x approaches to -1 f(x), is equals to -1/2. If they are not equal, meaning that this limit does not exist. Okay, this limit does not exist. If, let's say, the right hand limit is not equal to the left hand limit, then you can say that the limit of the x approaches to -1 does not exist. For this question, I have a function in absolute value, 3x minus 5/2. Then I need to determine whether this limit exists or not. Firstly, you need to define your function into two subfunctions, which the first one is your 3x minus 5/2 when your 3x minus 5/2 greater or equals to 0. Or it can be written as a negative of 3x minus 5/2 for the 3x minus 5/2 is less than 0. This one, I actually use the definition of the modulus. That is my modulus of x equals to positive x when the x is greater or equals to 0. And it can be written as negative x when the x is less than 0. So now our x just change into the 3x minus 5. So you just replace this x into the 3x minus 5/2, 3x minus 5/2, the same as this one. Alright, then after that, I'm going to simplify this interval so that I can determine when I find the limit of f(x) when x approaches to 5/3 positive or 5/3 negative, I easily can determine which interval it fell into. Alright, so firstly, I got my first function, 3x minus 5. Simplify this, you will have your x greater or equals to 5/3. For the negative 3x minus 5 is defined when your x, simplify this or solve this, you get the x less than 5/3. This means that for any x which is greater than 5/3, your f(x) will take this function. For x is less than 5/3, your f(x) will take this second function. So now I'm going to get the limit when x approaches to 5/3. So to get this limit, we need to consider its right-hand limit and its left-hand limit as well. That is your 5/3 positive and 5/3 negative. So when the x approaches to 5/3 from the right, meaning that the value of x is a little bit greater than 5/3, the function we have to take is 3x minus 5/2, according to our definition over here. When the x approaches to 5/3 from the left, meaning that you can imagine that the value is a little bit less than 5/3, the function of f(x) to be taken is this one, the second function, which is your negative of 3x minus 5/2. Then, followed by the substitution method, we got 0. Substitute the 5/3 over here, you have your 3 multiplied by 5/3 minus 5/2, which you will have 0. And the same thing for the left-hand limit. Substitute the 5/3 negative, okay, into here. You got your 3 multiplied by 5/3 minus 5/2. You also will get 0. So what is our conclusion and the reason? The reason is when x approaches to 5/3 from the right, it is equals to the limit when x approaches to 5/3 from the left. And both of them equals to 0. Then we say that the limit when x approaches to 5/3 is equals to 0, and we say that it is exists. The limit is exists. For the example 7, you can see that the f(x) is given as a piecewise function for the interval less than 2, equals to 2, 2 to 5, and greater than 5. Now we need to determine the limit when x approaches to 2. So take note that when you've been asked to get the limit when x approaches to a value which is located at the boundary of the interval, which is the boundary value is the 2 and the 5 here. So we need to find its right-hand limit and the left-hand limit to prove that, to see whether it is the same or different. If they are having the same value, they define and having the same value, then we say that this limit exists and equals to the value that we get. If they are not equal, meaning that this limit does not exist. Alright, so this is the concept that we were going to apply. So let's look at the question A. To evaluate this limit, I'm going to get is the right-hand limit first. So right-hand limit is the 2 positive when x approaches to 2 from the right side. So 2 positive, you can just plug in a value 2 positive, for example, 2.0001. Okay, ask yourself 2.001 fall in which quadrant? All right, a value which is a little bit greater than 2 is fall in this quadrant. Sorry, this interval, and this interval is tally with this function that is your 2x minus 6. So you put in your 2x minus 6 as your f(x). Then you evaluate. Substitute the 2 inside, you will have a 4 minus 6, that is negative 2. So this is the answer for the right-hand limit. And now we continue with the left-hand limit, which x approaches to 2 from the left side. So 2 from the left side, meaning that you substitute a value which is a little bit less than 2. See the value 2 negative is fall in which interval? 2 negative is somewhere over here. Then the function tally with this interval is x minus 4. So you just put in the x minus 4 here. Then substitute the value, you have a 2 minus 4 equals to negative 2. Then we say that since the limit from the right side is equals to the limit from the left side. Both of them equals to negative 2. Then our conclusion is limit when x approaches to 2 for the f(x) is equals to negative 2. Okay, just by consider these two values. If they are equal, then we say that the limit when x approaches to 2 will be exist, and it is equals to negative 2. Alright, then come to the question B. We need to determine the limit exists or not for x approaches to 5. Again, the x approaches to 5. The 5 is the boundary value over here. You can see the 5 is over here. So to determine the existence of this limit, we need to determine its right-hand limit and also the left-hand limit. So the right-hand limit is defined by this. Limit when x approaches to 5 positive. So you need to put the f(x) over here, the corresponding f(x). You need to determine whether the 5 positive is fall in the third interval or fourth interval. Okay, 5 positive means that a value which is a little bit greater than 5. So this function we have to take, that is your square root of 14 minus 2x. Then after that, just put in the 5 inside by substitution method. 14 minus 10, you got a 4. Alright, you got the square root of 4. And then after that, you have 2. So just leave it first, then we proceed to the 5 negative. When x approaches to 5 negative, the function of f that we have to take is the 2x minus 6, because 5 negative, for example, is a 4.99999. 4.99 is somewhere located in this interval. So we need to take the function, the corresponding function is 2x minus 6. Put in the 5 into here, you have your 10 minus 6, that will be equals to 4. So now you can see that both function, both limit, right-hand limit and left-hand limit, they are having the different answer. We say that when x approaches to 5 positive is not equals to the limit when x approaches to 5 negative, meaning that the right-hand limit is not equal to left-hand limit. So what is our conclusion? Conclusion is limit when x approaches to 5 does not exist. We have to make conclusion, does not exist. Alright? For this question, we need to evaluate this limit and hence evaluate this limit. Okay, you can see that something is similar within these two functions. But here we have a cube root of this function. So we need to apply the properties later on. So before this, I just evaluate this first. To evaluate this limit, firstly, we need to use substitution method. Substitute this negative 5 inside, you get 0 on top. And substitute negative 5, you get 25 minus 45 and plus 20, you will get 0. Alright, so to evaluate this limit, we need to factorize first using the method of factorization. To factorize this x cubed x cubed plus 125, again, I will apply the long division. Okay, divide by its factor. Its factor is x plus 5 because the negative 5 is the 0. And from the 0, we can know that the factor is x plus 5. So divide by x plus 5. This is the long division that I have done. You can see that once I take this polynomial of cubic divided by x plus 5, I got my quotient to be x squared minus 5x plus 25. Means that this cubic polynomial, it can be replaced by x plus 5 multiplied by the x squared minus 5x plus 25. And this is going to be divided by this quadratic, and I need to try to factorize it. Factorize this quadratic, I got 5, 4, plus. Okay, you can expand back, see if you got back this quadratic expression. So after you have factorized, you can see that there is x plus 5 at the numerator and the denominator. We can actually cancel it off. And now we can directly use substitution method. Substitute negative 5 inside, you have negative 5 squared minus 5 multiplied by negative 5 plus 25. And this is divided by the negative 5 plus 4. Alright, so you have your negative 75. Alright, this is the answer for the first limit. And hence, you need to evaluate this. To evaluate this, you do not need to recalculate, to re-evaluate the limit. You just need to apply this property. Alright, when x approaches to the a, for example, you have a fx power of n. Alright, or you say that the cube n root, you can say that is n root of fx. If you have this kind of function, n root of the fx, you can actually apply this property. Okay, the n root you bring out, you have your limit inside. This is one of the property of the limit. So now I'm going to apply this property into my question now. Originally, now the question is asking for this cube root of x cubed plus 125 over x squared plus 9x plus 20. This is the question. See or not? This is a question. So now the question, especially a word hence over here, is actually giving us a hint that we need to use the result above to answer this question. Alright, so now I apply this property. I bring out this cube root. The cube root I bring out, and then all the limit I put inside. I got my x cubed plus 125 over x squared plus 9x plus 20. So you can see that if once I apply this property, this answer actually, this limit inside this cube root, already got it just now that the answer is negative 75. So you just can substitute negative 75 as the answer of this. And after that, you just can give your answer in a decimal number. That is your negative 4.22. For this question, you need to find, okay, this is a guided question, just asking you to find the left-hand limit for the 0. And when x approaches to 0 negative, it's 4 in this quadrant, this interval. So you can substitute this fx as a function of 1 plus x squared. Then put in the 0, you get 1. Then you got the right-hand limit when x approaches to 0 from the right. So pick the function which is corresponding to the x approaches to 0 from the right. That is your 0 positive. So 0 positive means a little bit greater than 0. You just put in the function as a 3x plus 1. The 0, again, you substitute in, you get 1. Then does the limit of x approaches to 0 exist? You say yes. Yes. Limit x approaches to 0 of fx is equals to 1, and we say that it is exists. Alright, state your reason. Reason is because the limit when x approaches to 0 from the right is equals to the limit when x approaches to 0 from the left. This is your reason. Okay, and is equals to 1, so you say this is a conclusion. Alright. For this question, is similar to the question 9. We need to find this limit. Okay, we need to get its right-hand limit and left-hand limit. Then only we can make conclusion whether this limit exists or not. All right. To get this limit, I got the x approaches to 4 positive. 4 positive is somewhere here, so I'll take this function as a x minus 4 squared plus 7. Okay, then you substitute in your 4 inside, you get a 0 plus 7, that is your 7. Then check the left-hand limit as well. The left-hand limit, when x approaches to 4 negative, which is 4 in this interval, put in the corresponding function. You have your 3x over 5 plus 9. Substitute your value of 4 into here. You get a 12 over 5 plus 9. Very obviously, this is not having the same answer with the x approaches to 4. Got it, 57 over 5. So what can you say? All right, you can say that the limit since the limit when x approaches to 4 from the right is not equal, write down the fx, is not equals to the limit when x approaches to 4 from the left. Alright, then you say that your conclusion is the limit of x approaches to 4 does not exist. Okay, you got to write in this way to get the marks. Then after that, you need to get the limit when x approaches to 5. So since this is a piecewise function, and the 5 is actually located at the boundary, alright, boundary value, you need to check is the right hand limit and the left hand limit. So when x approaches to 5 positive, meaning that the function is a 2 over 3, 7 plus x. To evaluate this, just put in the 5 inside. You got 7 plus 5, that is 12. 12, that is 24 over 3. Then check the left hand limit as well. That is your x approaches to 5 negative. 5 negative, the function is x plus x minus 4 square plus 7. Then we put in the 5 inside. 5 minus 4, 1. 1 square, 1. 1 plus 7, 8. Again, left hand limit is not equals to the right hand limit. This is my reason. Left hand limit, right hand limit is not equal to the left hand limit. Then my conclusion is the limit when x approaches to 5 does not exist again. Okay, does not exist, sorry. Okay, so the end of this, our topical practice for the topic 1 limits. Thank you for watching. Sorry, there is some correction over here. 24 over 3 is equals to 8. So both of them having the same value, we can say that the right hand limit is equal to the left hand limit. This is equals to 8. That's why we say that does exist. Alright, the limit when x approaches to 5 exists, and it is equals to 8. So just make your conclusion. This is equals to 8. Alright, thank you.